Indefinite integrals can be really very difficult. One of the reasons is because they have very few properties. Actually, all the properties that I will show you now can be summed only as one property, which is linearity. The integral of a constant times a function dx equals to the constant times the integral of the function. And the integral of sum or difference of functions equals to the sum or the difference of the integrals. If you put those together, you just get linearity. For example, what is the integral of x cubed plus 5 sine x dx? Now, because I know the antiderivative of each one of the pieces, I can put everything together, use linearity, and get a solution. So first, I'm using the fact that the integral of a sum is the sum of the integrals, and then with the second one, I'm using the constant rule, and I get that. This is the power rule when n equals 3, and to recall, the antiderivative of sine x is negative cosine x plus c. So we get x to the power of 4 over 4 from the first one, plus 5 times negative cosine x plus c. We can check. We will differentiate the answer and we should get the integrand. As you can see, this is indeed the integrand. It means that the answer is right. To save time, I'm not going to check all the time, only very rarely, but when you do your homework, it's a really good idea to check by differentiating the answer. Example. The integral of fx dx is cosine x to the power of 2 plus c, and the integral of gx dx is x to the power of 2 e to the x plus c. We would like to find what is the integral of 3 times fx plus 2 gx dx. Because of the linearity, I'm going to break it down like this. I know what is this guy and I know what is this guy. Putting everything together, I get this. But now observe, I get c1 from the first integral, the integral of fx dx. Then I get another constant from the other integral of gx dx. But the magic of those constants that I can combine them together. A constant plus a constant is another constant. Because the constant here can be really any real number, if you add up all the real numbers to all the real numbers, you will still get just one time all the real numbers. So when you are combining those constants from the integration, then any combination of those constants is just c. We say that the set of all real numbers is closed under addition. It means that if you add all real numbers to themselves, you will still get all real numbers. This is also true, by the way, also for a product. If you will take all the real numbers and you multiply them by all the real numbers, you will still get all the real numbers. Example. The integral of 1 over x plus 7x plus 6 minus x to the power of 2 dx. We will use here the power rule, and also because we have 1 over x, we have to be very careful, and the integral of 1 over x is ln of x in absolute value. For all the others, I'm using just the power rule. Be careful with the integral of 6. This is like 6 times x to the power of 0. And when you add 1 to 0, you get 1. So you have to be really very careful. But obviously, we can just check in 1 second and when you check, you see that everything is indeed okay. You really have to pay attention actually for those very confusing antiderivatives. The integral of 1 dx is like the integral of x to 0 dx, and when you put this in the power rule, you get x plus c. Also, if you have good memory, you can just remember that actually the derivative of x is 1, so the antiderivative of 1 is x. But then if we use the constant rule, we will get also that the derivative of k dx is k times x plus c. Example, the integral of 5 times square root of x dx. We will have to write now all radicals and all expression of x to the power as x to 1 power. And we get that. We will use the linearity and also the fact that n equals 1 over 2 to get 5 times x to the power of 3 over 2 over 3 over 2 plus c. And if we simplify, we get 10 over 3 times x times square root of x plus c. What about this? There is no product rule for integrals, and that's why the only way to do this is just by really expanding everything and then use the power rule. So here's what I get in the first step of expansion. Now we just use the power rule and I will get that. And what about this one? I just need to express this as x to the power. And this is x to the power of negative 1 over 3. So I will use just the power rule. I have to know what is negative 1 over 3 plus 1. It's 2/3. And I get this. And again, I'm just trying to write it a little bit differently. You don't have to right now. Be careful. The indefinite integral is only the linearity property. As you know, here it is. The bad news is there is neither a product or quotient rules for integrals. Finding an antiderivative of a product of two functions can be very difficult and may require advanced math skills. Remember that no matter how difficult it is to find an antiderivative, it is always possible to check the answer by differentiation. We will finish this section by doing an example that is very applied, at least in physics. The acceleration of a falling object due to gravity is g ft over secant to the power of 2. Find the height of this object at any second given that its initial velocity is 3 feet per second and its initial height is 200 feet. Let's write what is given. We have at, the acceleration, we have v0, the initial velocity, and we have the initial height. We know that if we will differentiate the velocity, we will get the acceleration. It means that if the acceleration is given, we can get the velocity by taking the antiderivative of the acceleration. And we get g times t plus c. We have to find c. For this, we are going to use the fact that the initial velocity v0 is 3, and we are going to substitute 0 for t and 3 for v of t. And we get the 3 equals g times 0 plus c, and from here c is 3. Because we have that, we are going to replace now the equation for the velocity. We have a better equation. It is g times t plus 3. Now we will continue building up. We know that if we will differentiate the height, we will get the velocity. It means that to get the height, I need to take the antiderivative of the velocity. So it is the integral of gt plus 3 dt. We will use the power rule for the first part, and we will get g times t to the power of 2 over 2, and the integral of 3 dt is 3 times t. And we get that h of t is g times t to the power of 2 over 2 plus 3 times t plus c. But again, we have to find c. For this, I'm going to use the information about the height at time 0. Let's substitute. T is 0 and h is 200. And I get that 200 actually equals c. So I have my c to be 200. Let's now substitute the 200 in the c in h to get the height. The height at any time t is given by g times t to the power of 2 over 2 plus 3 times t plus 200 feet.